All right, so today we're going to be looking at this will be on the classwork from the week of November 29th. We're going to be looking at power and work on this one. Actually, we're just going to look at work on this one. So, in this problem, we have Hans Full is pulling on a rope to drag his backpack to school across the ice. He pulls upward into the and rightwards with a force of 22.9 newtons at an angle of 35 degrees above the horizontal to drag his backpack as soon as Riley gets back. 129 meters and determine the work done upon the backpack. So when we determine the work, I know that work is going to be force times distance. And in this case, our force isn't only in the x direction. We have a force that's in the x and y direction. So with this vector, we need to go ahead and separate this vector into its x and y components. All right, so I know that this is going to be my force in the x direction. Here would be my force in the y direction. And this would be some angle theta to the horizons. All right, so we know the bag is going to be traveling only in the x direction. So when I look at the work is only being done in the x direction. In order for me to do work in the y direction, the bag would have to come off the ground or be going through the ground. So here, we need to find the force in the x direction to calculate the work that's done, since he's only traveling in the x direction. So if I want this vector here, I know this one and I know this one. So angle, side, I can find the other sides. All right, so we'll use a little bit of trig. So I know that this is adjacent. And then over here, this is across from our right angle. So that's hypotenuse. All right. So then the trigonometric function that relates the adjacent side to the hypotenuse is going to be cosine. So cosine theta is equal to adjacent f of x over my hypotenuse. And then if I want f of x by itself, I can just multiply this side by f. I also need to multiply this side by f, cancel, cancel. And then I'm left with fx. My force in the x direction, that's going to be equal to f cosine theta. Okay, so now I can find this force in the x direction. I'll take given information. So we do have some given information. My force is going to be equal to 22.9 newtons. Some angle theta, which is 35. And then the unknown they want me to find is work. And we also have a distance traveled of 129 meters. All right. And so now we'll take 22.9 times the cosine of 35. And then that's going to give me f in the x direction. All right. Cosine times 22.9. All right, so now we have force in the x direction is 18.76 newtons. All right, and then when we look at the work equation, work is just going to be equal to force times distance, and in this case, we're only working in the x direction. We didn't have any y travel, so my force in the x direction is 18.76 newtons times my distance traveled, which is 129 meters. So we'll end up getting 2419.86, and then this would be a Newton meter. You might see it in scientific notation, 2.4 times 10 to the third joules. All right, so we can change a Newton meter to a joule, and I just put this in scientific notation. 1, 2, 3. All right, so if we have something that's being pulled at an angle, we need to separate that into its x and y components. And then once we separate it into its x and y components, then we can look at work or power or separately in the x direction. If something's moving up or down, we can look at it in the y direction.